The general term of the given series is equal to k square divided by k plus 2 factorial. Now add 3k plus 2 to the numerator and subtract the same quantity. The first three terms in the numerator, k square plus 3k plus 2, can be written as k plus 1 times k plus 2. The next term in the numerator is minus 3k. And finally, minus 2 can be written as minus 6 plus 4. The denominator is k plus 2 factorial. Now this can be broken into three components. The first component is k plus 2 times k plus 1 divided by k plus 2 factorial. The next component is minus 3 times k plus 2 divided by k plus 2 factorial. And finally, plus 4 divided by k plus 2 factorial. The general term therefore simplifies to 1 upon k factorial minus 3 divided by k plus 1 factorial plus 4 divided by k plus 2 factorial. The sum of the given series to infinity can therefore be written as summation of the above general term where k goes from 1 to infinity. This is equal to summation 1 upon k factorial where k goes from 1 to infinity minus 3 times summation 1 upon k plus 1 factorial plus 4 times summation 1 upon k plus 2 factorial where k goes from 1 to infinity. In the second term, put k plus 1 is equal to j. So when k is equal to 1, j is equal to 2. And in the third term, put k plus 2 is equal to I. Therefore, when k is equal to 1, I is equal to 3. The sum of the series can therefore be written as summation k is equal to 1 to infinity 1 upon k factorial minus 3 times summation j going from 2 to infinity 1 upon j factorial plus 4 times summation I going from 3 to infinity 1 upon I factorial. Now we recall that 1 plus 1 upon 1 factorial plus 1 upon 2 factorial plus 1 upon 3 factorial plus and so on to infinity is equal to e. Therefore, 1 upon 1 factorial plus 1 upon 2 factorial plus and so on to infinity is equal to e minus 1. This can also be expressed as summation 1 upon k factorial where k goes from 1 to infinity. This also implies that 1 upon 2 factorial plus 1 upon 3 factorial plus and so on to infinity, which can be expressed as summation j going from 2 to infinity 1 upon j factorial is equal to e minus 1 minus 1, which is equal to e minus 2. And finally, this also implies that 1 upon 3 factorial plus 1 upon 4 factorial plus and so on to infinity, which can also be expressed as summation I going from 3 to infinity 1 upon I factorial is equal to e minus 2 minus half, which is equal to e minus 5 upon 2. Substituting these results in the expression above for s, which is the sum of the given series, the first term is e minus 1, the second term is minus 3 times e minus 2, and the third term is plus 4 times e minus 5 upon 2. Collecting all terms with e, we get e times 1 minus 3 plus 4, and the remaining terms are minus 1 plus 6 minus 10. And therefore, the sum of the given series simplifies to 2e minus 5, which is the required answer.